Now then, we got under the number 1, and we're talking basically about a particular type of scope. There's a handout on it, you know, which is not really a big deal. But what I'm going to do is I'm going to ask you that first one. You ought to adjust the coupling under the voltage menu to AC when viewing what? What do you got to have it set on? You got to have it 5-volt square waves, sine waves, pulses, or grounds. You know what a sine wave is, right? Looks like camel humps. You know, whoop, whoop, whoop. So if it's AC, if it's going above and below 0, you're going to be basically looking at your camel humps, right? Which would be your sine wave. Is that right? You think that would be correct? Like B? Lab scopes are also known as what? Lab scopes. Today's lab scopes, the ones that we have now, are also known as digital storage oscilloscopes. The reason we call them digital storage oscilloscopes is because they will grab a pattern, you can save it, and you can pull it up later and look at it. Now the ones that they used to make, like with the CRT tube, the little, you know, thing on the, you know, black screen with the blue going across it, you couldn't save nothing on there unless you took a digital camera and took a picture of it. And I used to do that a lot, you know, when we had one of those here that worked, but it finally died. Okay, number 3, which of the following components generate a 5-volt square wave? Transmission output speed sensor, crankshaft position sensor, intake air temperature sensor. Huh? B would be, you say crank position sensor. I guess it depends on what kind of vehicle you're talking about, but you're right. Crank position sensor creates a square wave signal, and it's been that way for a while. After setting the display option, now not all crank sensors do that. Remember that. Unless it's a Hall effect crank sensor, you're not going to get a square wave anyway. If it's a variable reluctance sensor, you're going to have an AC signal coming out of that. One of the things I thought was interesting was in the these, like the Ranger and the ones, the Fords, that had these cam sensors where the distributor used to be. Early on, they started out with one that was a 3-wire sensor that would put out a square wave, and then they went to a variable reluctance 2-wire sensor that made a sine wave. And it was kind of aggravating to set because it's got to be crossing that crank sensor pattern 8 pulses past the missing tooth, which is tricky to do even on an oscilloscope, but you can do it. On my Jeep, when I set the sensor on it, I used that new scan tool I bought, and I took that and I went over there to the looking at the sync signal, and it said it was at 16 degrees and it was supposed to be 0, and all I had to do was just loosen that little thing where the distributor used to be on the side of that Jeep and turn it until it read 0 and then lock it down, and that was set. It took about 6 minutes total, you know, really handy on that. Let's see, after setting the display options at the scope setup screen, which key do you press to enter the live data mode? Now that's a sort of a, you know, you have to have the thing in front of you and have used it and all that to pretty well answer that question. But the answer to that is C. You're going to mesh F3. Function keys operate the same whether you're in the live data mode or reviewing recorded scope events. Is that true or false? No. And that's going to be true. Okay. Besides injector pulse width and ignition primary signals, what else can you check with option 9 of the program screen displays? How would you ever know that? You know, well, you imagine a question like that. Usually, like I say, I give out a handout with this, but you're probably never going to use a scope like that, just like that anyway. But this is sort of a generic kind of a test that I can just throw stuff. Basically, relay operation is what they're wanting to see there. And Technician A says, when checking fuel injector patterns on a 3.5 liter engine, the 6 injector patterns should look nearly identical, while Technician B says injector patterns that have different amplitudes are no cause for concern. Is that Technician A or Technician B? That's Technician A. Finally, the 4 trigger settings for the DRB3 lab scope are auto, normal, single, and what? That's going to be B, manual. A waveform displayed on a lab scope is basically a graph of what? You ought to be able to answer that without me telling you. Over. Voltage over time. There you go. Number 10, the DRB dual channel lab scope display is divided into blank divisions vertically and blank divisions horizontally. How many and how many? It's going to be C, 5 and 7 on the DRB. The horizontal and the vertical ones, okay, now, are basically the horizontal ones are going to be the ones that's time and the vertical ones are voltage. All right, now I'll show you something else here right quick. And we're going to look at this this thing here on the board. Let me fire up my media projector again. And I'm going to see what you guys know. We'll see what you know. We'll see what you know right here. All right, I'm going to close that up. I'm going to zoom in on that screen so I can see it. And then we're going to talk a little bit. Some of this stuff I've already covered with you guys, but I need to talk about it again. And I got 5 questions on here that I'm going to ask you about this. And I will say that typically whenever if Sean has heard something before, he usually burns it in pretty well. But right here, we've got a dotted line. See that dotted line right there? It runs across there. And you tell me what that dotted line means. This is part of your electrical training. We've talked about this.
Connectors there or something.
Is
There are
that,
connectors there.
It's got power.
yeah, you're very close. A dotted line is never going to indicate power, and it's never going to indicate ground or wire schematic. It's like not like this. What this is, and just remember this, then take it to the bank. That dotted line means all of those wires are going through the same connector shell. You see this connector right here? It's got a bunch of, wires going to it. That means that the cavity numbers, 60, 57, 47, and 59, you'd find the cavity numbers, and if I had given you the whole picture of this, you would find the entire, all those cavity numbers would be laid out, so you could tell which one you were supposed to be looking at. I like to look at the cavity and see if the wire color is the same. All right, so now let's go back to this. Okay, right here, what does 0.85 mean right there? See that 0.85 R-W? You know R-W is going to be red white.
Is that in thickness?
Yeah, that's good, and it's metric. On the metric ones, if you see 1.0, it means the wire is a millimeter thick. If it's like on that Volkswagen out there, the wire that's feeding the glow plug relay is actually a 6 millimeter wire. It is a huge wire. You see it on the schematic, it says 6.0. All right, look at this one up here. That says 1.25. You got me? So that means that is a 1 1/4 millimeter wire. And so it's a bigger wire than this one. This is a white wire, it's 1 1/4 millimeter. All right, now then, question number 2. What has to happen in order for the fuel pump to receive power? Now this is a 2005 Dodge Stratus Coupe, MFI. Okay, so tell me what has to happen in order for the fuel pump to receive power. And what's unusual about this fuel pump setup? This is something that you don't hardly ever see. Find the fuel pump. You know where the fuel pump is? You see it? It's on that schematic.
Right there.
The actual fuel pump.
Is that motor right there? Yeah.
That's
I've
it.
seen that.
That's the motor.
It's module, so I was thinking it was some kind of box.
Okay. Are y'all gonna come out here just to service media for the contract changes?
Turn on other ignition.
From what I understood, they
Maybe
thought that you
switch the
were
ignition
swapping
on,
the-
use power to the relay.
I can, but my contract goes to June.
Um,
You just need to, I'll swap with them, but you just need to raise me for my contract. I want to get
Yeah,
it for $200, $400, $500 worth of charges.
yeah, we'll probably work this through the contract runs out, unless you wanna stay with it.
Well, the contractor, like Jake, runs out in June, but find out from the service manager what he wants to do about that. Because probably a pain for y'all to come here and just to service me. It doesn't really matter. Put those on my desk. Get in here, Brandon. All right. You're 2 days late. All right. 2 days. Go. You have stuff to do. All right. Okay, so tell me what's unusual about this. Sorry about the interruption. The dual uniform guy. What do you think? What do you see up here that you don't usually see on a vehicle? Look at that and that.
2 relays.
2 fuel pump relays.
Yeah.
What this Sam Hill is that all about? And how do they work? All right, on this particular one here, the battery feeds that one all the time, right? Okay, the voltage stops there though. Now this is the second part of it. in order for that thing to receive power, and that's basically the number two question, this relay has got to be energized, and then that relay has got to be energized before the fuel pump will come on. You got to have two you got to have, if this relay doesn't work, first, if this fuse is blown, what will that do? What happens if this fuse is blown? What does that do to those? What does that fuse feed?
Fuel pump and
It feeds the coals.
Bingo, that's the answer I was looking for. And see, did you hear him? Hey, Cameron, did you hear him? He said, it feeds the coils. And you were like, I couldn't understand what
everything.
you
I'm talking to
said.
myself.
Okay, that's fine. All right, but anyway, right here we got 7.5 amps. Fuse feeding the coils on the relays. If that blows, neither relay is going to work and your fuel pump dead in water. Got it? Okay, let's say that fuse is good. Well, look at here. We're going all the way down here, and we've got the engine controller actually reading that. See there? That's a ground, the transistor. All right, is that controller going to do something, or is it just reading something? This is a voltage, the current limiting resistor here. Isn't that an unusual situation there? Do you think maybe that engine controller may be monitoring that to see if that's got good voltage feeding those relay coils? I haven't really studied that. I'm just looking at a schematic, okay?
Well, when you turn the key on and turn on the fuel pump, it shuts it back off.
For 2 seconds, yeah.
How does it work? How does that work?
The engine controller, when you wake the engine controller up, until if it doesn't see the engine spinning, it's going to just turn on the fuel pump, turn it right back on. They don't want the fuel pump running all the time.
That's why I know. That's what
Yeah,
I'm
so,
saying.
but, I mean, unless the engine's running, they don't want it running all the time. But that's how that works. The engine controller does that. When you wake it up, it goes, okay, I'm awake. That's what it does, basically. Now, if it sees the inputs coming that the engine's spinning, it turns the fuel pump back on. All right. And it also starts driving the injectors. And whenever you're starting it cold, it pops the injectors twice as much. I mean, it puts more fuel. They're all together, poof, 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 poof at the same time. And then once it starts up, they start firing along in firing order. Like that. All right. But anyway, the long and short of it is, this power right here, when that relay is turned on by what? The ignition switch. Watch this. It has no choice. This comes down here. This ignition switch, it does feed other stuff too, but it feeds this, and this relay is going to click when you turn on the ignition switch, and it's going to stay on, isn't it? All right, so that one clicks, and now you've got battery voltage available to that one. Okay, but it hasn't done anything until the PCM manages to operate this. Now, this is something else you got. Right here, you have got an Npn transistor. You know what that means? Negative, positive, negative. All right, look at it. If this part down here on the back of it that's going into the side of that transistor, that's actually the base. And this right here is the collector, and that's the emitter. And what that means is, if I put power into that third leg on that transistor, this applies ground to that. See, this ground is only allowed to go to that when there's power hitting the base. Now there's other resistors, there's other transistors that work the opposite way, where you put ground in there and they shoot power. You understand? There's two different types. There's Pnp and Npn. So basically just think of how many terminals it has. This one here has got 2 negative terminals and 1 positive terminal. Got me? All right, so whenever that engine controller shoots power into that base, it's going to fire up that relay right there. And that's going to close that relay, and then you're going to have fuel pump operation. And that's what happens for the 2 seconds when you first turn it on. And when you spin it, it starts happening really regularly. All right, so the power comes from here, goes through here, goes to there, goes through here, with the conditions met being the relays are energized. Okay, now then, what would happen if the male pin 21, if male pin 21 of connector C25 was pushed back and lost contact?
The relay would click.
No. You gotta look at where the connector is.
C25, that's in between the resistor and the relay.
Well, right here.
Oh, I saw a limited difference, C25.
See that? C25.
There's a
And pin 21 though.
Oh, yeah.
See, that's what I look at. There's pin 21 of connector C25. And down on the bottom of this, like I say, if I'd have shown you the whole thing, all these connector pinouts were down there, which is real handy right on that same page. See, they're trying to make it good for you. Now, your European automakers don't typically do quite that good a job, you know, but the U.S. automakers do pretty well on that. But anyway, I timed out and my aquarium came. Okay, here we go. So the long and the short of it is, if this pin was pushed back and I wasn't making a connection in that connector, what would that cause?
Nothing would work.
Huh?
Nothing would work. Engine wouldn't crank.
Why?
The engine controller's not hooked up.
Are you telling me that if I disconnect the wire going from the engine controller to the check engine light, it kills the whole engine?
You could have all kind of problems with your
Give me another
vehicle.
answer. Sorry, I'm eating cookies. I shouldn't be while I'm making a video.
You could have all kind of problems with your vehicle and a check engine light wouldn't show up.
Yeah, when you turn on the key in the service engine center, the malfunction indicator light doesn't come on. You got issues. Now, I will tell you this though. The engine controller, in a lot of cases, will tell you if the check engine light is out on a scan tool. On your airbag light, if your airbag indicator light's out, when you turn on the key, like on some of these Fords, like if you kill the airbag indicator, you'll get 5 beeps. Beep, 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 beep. Okay. Now then, there's some things you guys are going to have to do when I start throwing final exams. One of the things you're going to have to do, words to the wise, you're going to have to wire this up without a schematic so it'll work right. Can you do that? What does that mean? It means when you have a little time on your hands, you need to be practicing it. Oh, by the way, Brandon's going to have to do that too. That's something I'm going to make everybody that's in all of my electrical classes this time. We're going to have to wire this board up without a schematic so that it works just like it's working right here. They run at half speed, then they run at full speed. You better be able to understand that well enough where you can make it work without a wiring schematic. You can practice all you want to between now and then, and you're going to have a time limit. Got me? I know this is doable because one of the goofiest students that I had a couple of years ago, well, I guess the semester I built this was last year sometime. He got so excited about this, and he was goofy. He really wasn't all that great of a student, but he really got excited about this. And he got to where he could do that thing in about 5 minutes with no schematic. Click, 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 boom, click them on. He
Got his finger cut on the back of the fan too?
That was him.
Yeah.
Yep. That was Tyler. But anyway, he actually got to where he was super good at that. But the reason I put these little nets on the back of the fan was because, you know, I figured with them on the back of the board, nobody's going to get their finger in there unless they're trying to. But he managed to lay his hand up there and curl it around there, and the fan tipped his finger a little bit. Anyway, I went ahead and got that. And the problem is, if you stick your finger in the back of a fan, you're going to have some serious issues. Right? All right. Now
I
then.
got hit by the fan in the Bradley NBC system, and it hit my finger so hard it made it numb.
All right, but see that? This is the half speed and the full speed. Now, I made a video about this and put it on YouTube. If you study that YouTube video, I've even got a schematic showing the, you know, that I highlighted showing how the stuff flows. So if you go to YouTube and you study that and you practice this, you've got no excuse. You know, this is going to be a chunk of your hands-on final for electrical.
I'm going to go home and watch that video for 2 hours.
You can do that. That's all right. That's fine. I put it on there for you to do that with. There's other people. There's already a heap of people that have already watched it. I mean, quite a few. But anyway, the battery is self-contained, so I don't have to have an extra battery, battery on here. But this little board right here used to have more junctions. You know, they just put that little funky thing on there. But anyway, just keep that in mind. You can actually, I'm leaving this wired up so you can look at it and see how it's wired up. So you can, you ever try to cheat on anybody else's paper with spaghetti wiring like this? Ain't no way, man. Look at all that stuff. Can you do this, Brandon? Brandon, can you do this?
Do what?
Can you do this? You think?
With the schematic or without?
Without? Not yet, huh? You need to practice, don't you? All right then.
I don't think
All
I
right.
could do it with-
Huh?
I don't think I could do it with a schematic, just